Y'all.
Oh, take the lowest one.
The
Yeah,
lower,
subtract it from
the lower bottom and top.
And then divide.
Subtract or add?
Yeah, subtract. I mean add.
Add.
Divide
Add
by 2.
and
divide by
divide by 2. So, to get our midpoints, we're gonna do that and that, 61 plus 65 cut in half. Somebody who's good with the calculator real fast. And then we'll do these, 68 plus 65 cut in half. So what's that first red answer?
63.
63, that goes there. And the green answer?
66.5.
Okay. And then the next one is gonna be 70 plus 68 cut in half.
69.
Okay, so 63, 66 and a half. I'm gonna go back so we can type them in. Hold on. What was the first one? 63, 66.5, and then 69? Okay, and then it's gonna be 70.5, and then that's gonna be 72. 73 plus 77 cut in half.
You said 77 plus 72? 75.
75. Now, y'all, for this one, look, we don't have that, but we should know what that's gonna be. Because if this stops at 80, what's that gonna be?
81.
81. So it's gonna be 81 plus 77 cut in half.
79.
79. We good? All right, check answer. Check answer. Okay. Now, so I cannot put both of those numbers in. So I'm going to put in the midpoint as my L1, and I'm going to put the frequency in as my L2. So I'm going to come over here, going to come over here, going to do stat edit, going to clear out that bad boy. I'll be dag-nabbit, I didn't move to the other column.
Where are you getting those other numbers?
That table. is
That
the
little
Oh.
doohickey at the top.
Okay. Okay. I see.
96, 123, 83, 83, 10, and 46. My columns need to be the same length. So I've got my midpoints, and I just got my frequency from that little table right there. Then I'm going to do stat calc, 1 var stats. I am using 2 sets of data. So I have L1, and now I'm going to do L2. So the first thing they want to know, I'm going to hit done there. What do they want to know? They want to know the sample mean. So that's going to be my X bar. They want it to one place, so it's going to be 70.7. 70.7. And they want to know the sample standard deviation, so that's going to be my SX. So that's going to be to one place, that's going to be 3.4. Did that help?
Yeah.
You are not getting that other set of data.
That's
And
what
it's the
I'm
little
on.
things that get you.
Yep.
James, what was your problem?
I think I got it.
Okay. You just needed our presence, didn't you? All right, so, what is that? That goes away. Pull that over. All right, what we're going to be talking about in chapter 4 is regression, linear regression, the line of best fit, y equals ax plus b. Has any of us done linear regression? 2 out of 15. Oh, 3. Math 110, you do some linear regression? linear regression is I'm gonna be giving you a bunch of data points, real life data points. And what we're gonna do is we're gonna be finding the line that fits all up in that Kool-Aid. So we're gonna be trying to find the line that fits among all those points. That's the line of best fit. That's called the linear regression. So we're going to give you a bunch of points. You're going to graph those points, and then the calculator is going to determine the line that best fits those points. Okay? Now, this is called y-hat. That means that this is an imaginary line that fits up in those points. Y-hat equals ax plus b. A is our slope, b is our y-intercept. It's called the line of best fit. There's other names for the line of best fit. I tend to call it the line of best fit. Sometimes they'll call it a linear model, sometimes they'll call it linear regression. I told you math teachers are paid lots of money to confuse you, so we give all these different names to the same thing. Least squares regression line. So in your problem, it may ask you to do any one of those things, but they're just telling you they want the line of best fit. They want the y equals ax plus b. And the good news is the calculator is going to show you how to do this. I did turn this on, but my OCD's kicking in. Okay. All right. First thing that we need to know, in y'all math, a lot of y'all don't get math because you don't know the vocabulary. You don't know what it means. And once you learn what the vocabulary means, you're like, oh, that's all they're asking? Interquartile range, all they want to know is Q3 minus Q1. Oh. So once you know the vocabulary, it's not that bad. So we've got a little bit of vocabulary. Scatter diagram. Scatter diagram is just when I give you a bunch of points. This is the x-axis and this is the y-axis. Now normally in algebra you had the whole x-axis and the whole y-axis. And you had all these four quadrants. In this class, we tend to just look at the positive x-axis and the positive y-axis, and all of our points are usually in the first quadrant. Now, in Algebra 1 and Algebra 2, you wanted these points to make a straight line. And you freaked out if they didn't make a straight line. In real life, points don't always make a straight line, and it's okay. So for our scatter diagram, they may make a straight line or they may not make a straight line. And it's okay, because it's real life. But the scatter diagram is when you have points all over the place. The next word that we're going to talk about is the correlation coefficient. The correlation coefficient is a fancy name for the R value. The R value is going to tell us about the relationship. That relationship goes from -1 to +1. And I'm going to talk about the R value a little bit later, but it's going to tell us how linear it is. The closer to -1 it is, the more linear it is. But I'm going to talk about that in just a minute. We just need to know that the R value is the correlation coefficient. I promise this is all going to make sense. Don't freak out on me. The R value tells me how good is the fit, how linear it is. The residual's kind of like the leftovers. It's the difference between the observed value and the predicted value. And this formula is on your formula sheet. Let me double check, but I'm almost positive it is. Residual, yep. The observed value is actually what you did. You know, he ran a race and this is his time. The predicted value is what we're gonna get from the table. It's what didn't happen, it's what we say is gonna happen, what we predict. So the residual is what you did, which is your observed value, minus the predicted value, which is from your table. And when I give you two sets of lists, L1 always causes L2 to happen. The faster I drive, the quicker I get to work. The more I eat, the fatter I get. So L1 always causes L2 to happen. So the explanatory or predictor values are going to be your X, which is your L1. And your L2 are going to be the response values. So this is going to be like your cause, and this is going to be like your effect. Your X values are your L1, your Y values are your L2. It's your cause and your effect. One causes the other to happen. So when we look at a problem, we have to say, what causes what to happen? And it seems confusing now, but don't stress out on me. I promise it's going to make sense. So all of chapter 4, and we're only going to do 4.1 and 4.2, is talking about linear regression and how to do a linear regression problem and how to tell if it's a good linear regression problem and how to figure out the R value. So the first thing I want to do is I want to talk about the R value. So, I'm going to, let me move this down for just a second. Oops. Move this down and let's talk for just a minute. If I give you a picture of a scatter diagram, if it looks pretty linear, we say that the R value is close to 1. Okay? Now, if it looks like this, it's going to be close to -1. Positive 1 means it's going uphill. -1 means it's going downhill. And my mathematical car always travels from left to right. So if it's going uphill, it's positive. If it's going downhill, it's negative. And 1 means it's pretty linear. Okay? Now, if I have that, that would have an R value of pretty much 0. That means it's all over the place. Do you see that, it's like when you look at the stars and you can kind of see something. It's kind of scattered, but you can kind of see that it's going uphill. This would have an R value of, let's say, 0.6, 0.7. It has like a medium-ish R value. And if I do something like this, that would have a negative medium-ish R value because it's going downhill. So when we look at the R values, we do it on a scale of -1 to 1. So the closer you are to $1 or $, the stronger it is, the more linear it is. The closer you are to 0, the more it doesn't look like anything. And if it's in the middle, if it's like $0.50 or -$0.50, it kind of looks like a line uphill or kind of looks like a line downhill. So when I'm looking at these, hold on, scroll down for just a second. So all this means is that it's uphill because it's positive. And these just mean that it's downhill because it's negative. But when I get closer to 1, that means it's more linear uphill. And when I get closer to -1, it means it's more linear downhill. And the closer I get to 0, it's just a cluster. It doesn't look like anything. And when I'm in the middle, like the 50 cent, the 60 cent, the 70 cent, when I'm in the middle, that means it kind of looks like a line, sort of, kind of, uphill. And in here, it kind of looks like a line. So if you're in the 50 cent, 60 cent, 70 cent, 30 cent, 40 cent, it kind of looks like a line. Do we make sense? So if I give you some R values, and I want to know what do they look like, just put by R value. Would this be an uphill or a downhill?
Uphill.
Uphill. Would it look like a line or would it be all over the place? It would look like a line. So if I were going to be looking at this one, it would look, it wouldn't be a straight line, it would just be, but it would look very linear uphill. If I were looking at this one,
Uphill, but
it would be like a blah. That's like having no money. That's like being broke. You all over the place. So this one would be, that would be, you can't tell if you're going uphill or downhill. What about this one? Downhill, but it's not very linear. It doesn't have a good relationship. So I can tell that it's downhill, but I can't tell that it's a very good relationship. Yay? So the R value is really telling me the relationship between the X and the Y. If you're close to 1 or -1, y'all have a very good relationship. You're on the same line. If you have no relationship, y'all don't agree about nothing. If you have in the middle relationship, y'all agree on some things, but then there's other things y'all don't agree on. So that's your R value. All right. See if I can make this a little bit bigger. It says determine whether it's linear or not, and then tell me whether it has a positive or negative association. So for this one, is it linear? Does it make a line?
No.
No. Because if I look at this one, can you see that it goes shoo?
Yeah.
So we say this one is non-linear. That means it doesn't make a line. Is the next one linear or non-linear?
Linear.
Linear. Is it positive or negative?
Negative.
Negative. I'm going to go a step further. Is it weak, strong, or moderate?
Strong.
This one is strong because it's so the R value would be up there. It would be like 0.8, 0.9, close to 1. This would be strong. Okay, let's look at the next one. Linear or non-linear?
Linear.
Linear. Positive.
Moderate.
Moderate. What about the next one?
Non-linear.
Non-linear. So if I scroll down, I have a non-linear, I have a linear negative, I have a linear positive, and I have a non-linear. All right. This one, I gotta cover up my answers because y'all like to cheat. Get down here. This one says match the R value to the graph. So I have a negative 0.969. Now don't worry about where did the 969 come from. I gave that to you. I just want to know which one matches. A negative 969, a negative 1, a negative 0.049, and a negative 0.992. Okay? Negative 1, she zoned in on. The negative 1 is which one? That one goes here. It's downhill and it's very linear. Which one would I go to next?
A.
A for the second one.
I think D for the second.
Oh, yeah, no, D.
I would look at B right now. Where does B go?
B?
B is.
Number 3.
B goes here because negative .04 means you got a little bit of money, which means you all over the place. So B is gonna go here. Now, it's between those two. This one, D, is 99 cents. This one's 96 cents. So 99 cents is closer to $1. So the 99 cents is gonna be the more linear one.
So number 2.
Second one.
So the 99 cents is gonna go there. And the 96 cents is gonna go there. Y'all with me? And then I have my answers down there. Cool? All right. And then this is telling you that a perfect fit is gonna be that $1, a great fit, good fit, and then the lower you get, the crappier it's gonna be. All right, we're gonna do a good problem. I just made this one up. Okay. These are some countries, and this is their death rates and their speed limits. Now, before we can put it into the calculator as L1 and L2, I've got to know which one causes the other one to happen. Because when you're doing linear regression, you have to say, does death cause speed limit, or does speed limit cause death? Okay, so that's our first question we have to ask. Speed causes death, which means speed is going to be your L1, death is going to be your L2. Your L1 is always your cause. Your L2 is your effect. So it's not necessarily the way that it's written, so you've got to pay attention. Your speed is your L1, your death is your L2. So we're going to go to the calculator and do stat edit, stat edit first. Only do stat edit right now. L1 is your speed limit because that's what's, that is your cause. And the numbers have to match side by side, so if you screw up, make sure you put the right number beside it. There's 10 pieces of data. So right now we're asking ourselves, is there a relationship between how fast I drive and death? Is there a relationship?
Well, obviously not, you're standing there right now.
No. Speed and death, is there a relationship? Now, the first question I ask is, view a scatter plot. We have our data in there. How do you think we're going to view a scatter plot? Second y equals. So we're going to go to second y equals. Right now we have the box plot cut on. So we're going to go to enter, and our scatter plot is that very first one with a bunch of dots. So I went to second y equals. And I made sure that I chose the scatter plot. And I'm going to do zoom 9. Maybe not. Is it grab furthest? There we go. It didn't like it, that one. Okay. So what the graphing calculator did is it treated this like an XY, and it graphed the point over 55 up 4.1, over 60 up 4.3. So it graphed all of these points. So over whatever, up whatever, over whatever, up whatever. So this is my scatter plot. So if it just says graph a scatter plot, that's gonna be your scatter plot. And all it's doing is it's graphing all of those points on your graph. Yay? Part A. Line of best fit, regression line, however they want to call it. Y'all, we have worn out one of our stats. We have done everything that we could possibly do to one of our stats. We are now going to use a new button. We're going to go stat calc. So on your test, you're going to have 2 stat calc buttons to use. We have done everything we can do to one of our stats. We are now going to use the one that's called linear regression. So go down to number 4. Enter, 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 enter. Now, who has not gotten fixed calc put on their calculator yet? Will y'all run next door real quick and get it put on your calculator? Just tell them you need fixed calc put on there. Now,
It's not on this one.
it's not on that one. We go right over there and get it put on there. I have A and B. I need more stuff on there. So, what you're gonna do is you're gonna hit the program button on your calculator. You already turned it on then. If you don't have more stuff, hit the program button, and it's gonna say fixed calc, and then you're gonna hit enter. And then you're gonna hit enter again to do it. And now do stat calc linear regression. I'm gonna have to I don't think mine has it on here. I'm gonna have to manually do mine. Give me just a second.
Mine
Yes.
didn't have that option, and also my numbers are different than yours, so I must have put something in wrong.
Okay, hold on, I may have put something in wrong. Does mine match y'all's? Stat calc linear regression. Does mine match y'all's?
Yeah.
I put 355s in.
No. No, it
It
doesn't.
doesn't match.
Ugh! Let me see what I did wrong. Stat edit 55.3, 55.3.3, 55.3.4, 73.5, 55.4.1, 64.3, 55.4.7, 65.4.9, 65.1, 75.6.1.
In there.
Stat calc. Oh, hold on. Does that look better?
Oh, we gotta take L2 off?
Yes, you gotta take L2 off.
Okay.
Yeah, that.
Yeah,
Yeah,
now
that's
my
right.
numbers match, but, what did you say we needed to do?
Yeah.
So we go to calc, linear.
Linear regression.
And how do you get more buttons? You hit program.
Does yours have a program on there?
I have no idea.
Okay, hit the program button and see if you have anything under program.
I do, I have, it looks like Excel, edit, and new are my options.
You should, when you hit program, up underneath it, it should say fixed calc. Do you have is yours on your phone? I don't know if they can download it on your phone or not. Okay, what you're gonna need to do, okay, go second catalog, second 0. Hit, this button right here, X to the -1. Scroll down until you get beside diagnostic on.
Okay,
And then once you get beside diagnostic on, hit enter twice.
okay. Oh, it gave me an error.
Did you get beside diagnostic on? Do second 0, second 0.
Actually, turned it off. I did second on. Okay, second 0.
And then hit the button with a D on top of it, which is X to the -1.
Okay.
And it scrolls down to the Ds.
Diagnostic on.
And then once you get the side diagnostic on, hit enter twice.
Yes, okay, I'm with
And
you.
now do stat over to calc and down to linear regression.
Okay, yes. So now it's gonna do that forever.
And now you're good.
Good.
Now, if you, when you go take your test, because y'all can't use your own calculator on your test. So we have a program that's called Fix Calc. And what you do is you hit the program button. It's not that, hold on. Let's do back in.